Hello everyone, welcome to another video. Today I'm going to be working on this PlayStation 5 motherboard. I bought this motherboard from eBay for £80 and I did pay a little bit much for this, but the reason I paid £80 for it is because number one, it's got no prior repair attempts, and number two, it comes with the disc drive daughter board. So if I can get this working, I can actually get a disc edition PlayStation 5 for £80 or whatever it cost me in parts on top. So I have just recorded some of this video and then realised I wasn't wearing my microphone. So just to give you the TLDR on this, this has got a 2-second blue light of death, and what that means is that the console will turn on for a couple of seconds and then it will turn straight back off again. When I first got this console, well, when I first looked at the board, it had a massive dry spot on the APU. So I have applied some fresh liquid metal to it. And the liquid metal I've used is my own custom liquid metal, which I do sell on my online store. It's going to be shipping in around about a week from today. It's the 21st of September. Sorry, no, it's the 22nd of September now because it's after midnight. But yeah, around about a week from now, it's going to be shipping. It is on pre-order at the minute. I'm just trying to get enough in stock to be able to, number one, cover the pre-orders, and number two, have some in stock to be able to sell at a later date as well. But I am making my own liquid metal, but I've applied some to this, and obviously it's not going to be an overheating issue where the console's just shutting off because it's overheating, because like I said, it has got fresh liquid metal on it, and this stuff is absolutely fantastic. So it could be a number of things. And I didn't realise that I wasn't wearing my mic until I went to connect up to UART. Looked at the looked on my desk, and there was my microphone just sat there. So audio would have been absolutely terrible. So sorry about that. But with that being said, my name's Hakko. I'm an electronics technician. I mainly work on games consoles, but I do work on other stuff as well. So if that's the sort of stuff you're into, be sure to get subscribed and turn on the bell notifications, and that way you don't miss any future videos. Turns out around about 60% of the people who watch my videos are not subscribed, so while I do appreciate it, it would really help me out if you hit subscribe and turn on the bell notifications, and that way you don't miss any future videos. If you do want to organise a repair, you can get in touch with me at thecoder.repair. The code is spelled the same way as it is here on YouTube, and you can just go to the website. You can either book it in and send it over, or you can get in touch if you want to get a quote, or if you've got any questions about the repair process, etc. So with that being said, let's get into today's video. Today's video is sponsored by PCBWay. Whether you've got a simple project that requires a quick mod board, or you want to launch your own products to the world, PCBWay can help. With fantastic pricing on multi-layer PCBs, flex PCBs, 3D printing and even laser cutting solutions, you're sure to get everything you need all in one place. Custom PCBs start from just $5 for a 1 to 2 layer board with a fast 24-hour build time and free shipping on orders over $30. PCBWay are also proud to announce their new aluminium PCBs, which start at just $120 per square metre. Check out what PCBWay have to offer by clicking on the link in the video description or the top pinned comment and get your project started today. Thanks again to PCBWay for sponsoring the video. Let's get back to the repair. Okay, so like I said, I was just about to connect up to UART, which stands for Universal Asynchronous Receiver and Transmitter. And that's basically a diagnostic tool which we use to connect the computer to the PlayStation 5 and get a error code which we can then attempt to interpret into something meaningful. So like I said, this has got a 2-second blue light of death, and that's not going to be caused by, for example, overheating, because like I said, I've got my own liquid metal on there, and even though the heatsink clamp isn't on here, it's still not going to overheat in that amount of time, right? So it's not caused by that, and I know that my power supply is good because this is my own test housing. So it's not caused by, anything simple like that. This is actually a blue light of death. And the backstory on this, just while I'm connecting up to UART, the backstory on this is that the person who sold this to me on eBay, he originally bought this to fix his own console. And I believe that he took the disc drive from the console and basically used that to repair his, and then sold the rest off for parts. And I have already had a look around the board, just with my eyes, not on the microscope or anything like that. But I've had a look around the board and I can't see any indication of any kind of a prior repair attempt. So I bought this board and I paid a little bit more than what I should for it, because I always need these for parts, and if I can fix it, then I've got a spare PS5 motherboard which I can use if I'm not able to, for example, fix a customer's console. I can, for example, offer them a board swap, you know, as a last resort. I don't like to swap boards, but sometimes it's the only option. For example, if we've got like a dead APU, or, you know, someone's got a banned console, you know, they can replace the board and stuff like that, and obviously get the, you know, the console up and running cheaper than buying a new board, right? So yeah, if I can't fix it, it's not a major issue, because I can always strip it down for parts. And like I said, I do sell the parts on my online store, so, you know, I'm always going to be able to make some money off it, right? I'm not going to lose any money on this. I will actually make a profit on this no matter what. I would make more money by stripping it down and selling the components individually, but sometimes it's good to have a board, you know, 1 or 2 boards just sitting around doing nothing, just so as you've got that option there to, for example, offer a board swap, or, you know, you could build a console. I could take some of my other spare parts like power supplies and disk drives, some of the stuff that doesn't sell as often as the components, build it into a console and basically sell it as a full console. That's always an option. But it really does depend on, number one, what's wrong with it and how much it costs to fix. You know, because even though I obviously supply parts, I'd still have to work it out based on a retail cost. So I'd have to treat it like any other repair, because the parts that I use on this I could potentially sell on my online store. So yeah, it really does just depend on what it costs to actually fix, you know, at a retail cost. And also, you know, is it going to fully work once I actually do get it working, if I actually get this working. But anyway, yeah, I'm going to connect up to UART, so I will connect up ground first and foremost. So I'll solder a wire to ground, which is going to be this N pin. I'll just zoom in here. So we've got an array of 10 pins here, and this very left pin on its own is going to be ground. And then we've got 2 other pins. We have a transmit pin, which is going to be the far right in the middle, and that's going to be the transmit pin that needs to be connected to the receive pin on the UART device. And then we've got the receive pin, which needs to be connected to the transmit pin on UART. So the reason that we flip them around is because you want to send it from the console and receive it on the UART reader, and you want to receive it on the console and send it from the UART reader. So you flip them around. So TX goes to RX, RX goes to TX. So we'll just do that now. So I'll use this Scene Great SG-C2303. It's a little USB-C UART reader, and yeah, this works great. So we're going to connect up ground. There we go. So that's ground. And TX on the reader, that's got to go to RX. So we're going to connect that up to my brown wire. And then RX to TX. So TX on the board is my white wire. So brown is my receive. That's all going correct. And then we've got ground, which is just ground. And we need to make sure this is connected up to 3.3 volts, not 5 volts. So if you're going to buy a UART reader, make sure it's one that does allow for 3.3 volts, just to make sure that it's going to work on the PlayStation 5. Some devices do take 5 volts, but most of them take 3.3. So once that's connected, I've got a USB-C cable, or rather that's just a USB-C female connector, but I'm going to connect that up to my male to male cable, just like this. We should hear it pop up on the computer. There we go. Yep, so that's lit up, it's all connected. So now we just need to apply power to the console, just like that. And then if we go over to my desktop, I'm going to load my own UART software. And you can download this on GitHub. It's completely free, it's open source, and yeah, you can just buy it, download it for free. You can do anything you want apart from sell it. So let's just have a look. So we're going to get the error codes from the PlayStation 5, which is option number 1. And then we're going to select the correct COM port, which is this one here, the PL2303. So that's COM19. For some reason, the past few days, it doesn't always do this, but for the past few days, it's been coming up as COM1 and COM19. But it won't work on COM1. I don't know why it's doing that. It's not just doing it on my own software, it's doing it on quite a few different pieces of software. So Yeah, we're going to select option 5. I know it's COM19, 100%. That's annoying. Okay, so we've got 8081 0001 and we've got C00C0002. So they're the error codes that we've got. So I'm going to clear those. So press option 2 and then press number 5 to select the device. And then I'm just going to reset power. And I've just realised I haven't got a ribbon connected to this. I'm just going to reset power, just power it on, and then I'm going to run the error code again. And we just got general power failure this time. Alright, so it looks like those codes are up to date, but I do always recommend just taking a mental note or writing them down somewhere and then reset the error codes and try and power it on again, just to see if we actually get the same issue or the same error code. Now, the problem with the 8081 0001 error code is it's a generic error code, and it could be a number of things. So it could be, for example, a shorted 5 volt rail, it could be a missing 1.8 volt rail. It's literally just a general power failure, and that just means that one of the power rails isn't able to power on, so we're not going to be able to fix it by using UART. A lot of the time, UART will tell us what's wrong, but in this case, where it's the 8081 0001, it can be a number of different things. I've had it be a shorted capacitor, I've had it be a blown fuse, I've had it be, for example, there was I think a MOSFET on the USB ports preventing 5 volts from getting through. And yeah, it's literally just generic. There's unfortunately nothing we can do about that. So we're going to have to investigate further and try and figure it out. The good news is no one's attempted to repair, so our chances are a little bit higher. So, with that being said, like I said, UART is not going to help us. So, I'm just going to desolder this. Absolutely pointless having that on there. And let's remove the board so as I can inspect it under the microscope. In fact, no, let's not do that. Let's check for some voltage rails first. Okay, so with the console in standby then, there's a few areas which I can use for testing voltage. So there's a pin just at the top here, and that's got 5.1 volts, which is normal. There's a pin just here for 3.3, that's normal. Do we get 5 volts here? So left side of F7002, we should get 5 volts, and we do. This is a EDM 020 board, so we should get 1.8 volts on this pad here, and we do. Okay, so that's grounded, and on this inductor here where the south bridge is, we should get 1.1 volts. When we power it on, rather, we should get 1.1 volts. And we do 1.14, so that's absolutely fine. We should get 5 volts here, which we do. We should get 2.5 volts, sorry, 2 volts there, which we do. We should get, I think it's 1 point something here when I power it on. Yeah, 1.2 volts, that's correct. And 0.8 volts there on the caps. And 2.5 volts there. Okay. So all of the voltage rails there are present. Did we get 5 volts here? We do not. Okay. We are missing 5 volts. It is trying to give 5 volts. So what I'm going to do next is I'm going to apply 5 volts manually to that rail. I don't think that rail is short, but I'm going to apply 5 volts manually to that rail and see if it wants to turn on. So there's a 5 volt rail just down here, which is absolutely needed to power it on. Without that, we're getting nowhere. So if I just give it 5 volts manually, and that is short. Okay, right. So instantly I got 5 amps of current at 5 volts, which means that we've got an issue with that line. It's likely going to be a blown cap. This might be nice and easy. So if I just apply 5 volts to this again, in fact, let's drain power from it first, shall we? So I'm just going to short out the capacitors just by pressing one side with the tweezers and connecting it to the other side. That's going to short out the caps and it should drain them. But then I'm going to do the same thing with the 12 volt rail as well. Just short it out, drain any excess power that's in the board, and now it won't give me a false reading. So now I'm going to just check it again. So if we just watch this screen just here, that's going to tell us the current draw when I inject directly onto this inductor. Yeah, 5 volts of 5 amps of current, and straight away I know 100% that line is short. Now the problem with that line is that this line does go to a number of things. So it goes to obviously this area on the back, so it goes around here, but it also goes to, for example, the MOSFET for the USB on the front. So it is part of the USB circuit. It's also part of, I believe, this circuit here as well. So we could have an issue pretty much anywhere here. So let's get the thermal cam out. I'll inject voltage again, and I'll try and pick up where the short is with heat. So the reason we use a thermal camera when we're trying to find a short is because when basically electricity is always going to take the path with the lowest resistance, and that means that it's going to look for the easiest route, and the path with the lowest resistance is always going to be the shorted component because it's dead short to ground. So it's going to have basically no resistance to ground, and the electricity is going to want to flow through that component. So for example, a shorted capacitor would have a very, very low resistance, and that would basically cause electricity to want to flow through that. That would cause the component to get hot, and basically, yeah, it's just going to get really, really hot, and we're going to be able to pick it up with a thermal cam. The thermal cam I use, not sponsored, although I did receive this for free from Infrared when I first had it. I did a review on it. I did leave a review on the channel. But when I use the thermal camera, I use the, I'm mixing my words up now. I use the Infrared P2 Pro. And like I said, this isn't sponsored, but this is an absolutely fantastic bit of kit. The Infrared P2 Pro is far better than the, for example, FLIR cameras. You know, just based on resolution alone, let alone the fact that, number one, on the FLIR cameras, the images are never aligned properly, whereas on these they are. But number two, the response time as well. So, for example, the frame rate, you can actually see what's going on. And they do come with a macro lens, which allows you to look up closer to an individual component and pinpoint the exact component which is getting short, rather than just a general area based on a heat signature. So, not sponsored, but I dropped it. It's a fantastic bit of kit, and yeah, I really do recommend it. I'll leave a link to this in the top pinned comment. It will be an affiliated link, so if you do buy it, I will get a little bit of a kickback, and it does help out the channel. So if I connect this up to the computer, then I can load up the software. Now, the software for this thermal camera in particular, it's not the official software. I use the same software that's used for the top-down thermal cameras, and the driver is the same. It does work. It's probably the same company, actually, to be honest. I'm not sure, but yeah, if we just inject into this area here, this should light up like a Christmas tree in a minute. There we are. So where is my short going to be? Okay, looks like it's going to be on the back of the board. So I'm seeing a heat signature here. I can connect up the macro lens and see if it is an actual component here. So you'll notice now that it's gone blurred. But if we just look here, and no, the area which is getting warm, there's no component there at all. It's completely blank. So the short is going to be on the other side of the board. So if I just do this again where I did it just, which is where I normally check for 5 volts, we're going to find, or we should find, a shorted component. And it's that cap right there. that exact capacitor, which we were testing 4.5 volts, is short to ground, and that is likely what's causing the issue. So let's pop under the microscope. I'm going to remove that capacitor, and yeah, then we'll just see if it turns on. Well, I'll replace the capacitor first, but we'll see if it turns on. So now that I'm actually looking at it under the microscope, I can actually see the faulty component. So it's this capacitor right here which was getting hot. So I'm going to use some hot air. I've got my hot air set at 440 degrees Celsius at 40% airflow. And there we go, that component is removed. So I'm just going to add a little bit of flux here. And I'm just going to tin this area ready to accept a new capacitor. I'm going to use some leaded solder, which by the way you can buy from my online store. Proper Kester leaded solder. What I do is I buy it in bulk and I just basically strip down the reels, because you can't buy it in the UK. So I basically just strip down the reels into 50-gram packs, and yeah, that's what you'd receive if you bought it from me. So in terms of a donor component, I'm going to remove this one from this donor board. There we go. One thing I will say as well is, yes, you could probably get away with not putting a capacitor on here, but I always recommend, especially if you're doing this for customers or you're doing it to resell, I recommend putting a capacitor on it. But there we go, that is all done. And that was out of focus because I'm an absolutely terrible YouTuber. Never mind. Let's just clear this up. I'll just use a little bit of 99.9% isopropyl alcohol. One thing I'm going to do is just skip around the board, and I'll do this without the microscope because, well, it's pointless having the microscope there, it just gets in my way, to be honest. I'm just going to skip around the board and I'm just going to check all of the fuses. So basically the important fuses to check are going to be this one here, this one here, this one here, and there's two here as well. Sorry, three here that we need to check, and then also one on the back. So the reason I'm checking these fuses is mainly because I've injected voltage, and these fuses are not rated for 5 amps of current, which is why they blow. But yeah, let's just check these fuses. We need continuity mode. So let's just check. That one's good. That one's good. That one's good. If anyone's going to be bad, it's going to be 3501. And that one's not bad, actually. Cool. 7501 is good. And 3502. Where are you? There you are. Okay. Fuses are all good. You didn't blow them. Interesting. They're not rated for 5 amps. So why they didn't blow, I do not know. F7002 again is absolutely fine. Strange. That should have blown at least F7001 because, well, F7001's a 5 volt set. Damn it, wrong area. F7001 is a 5 volt circuit, and the current would have been flowing through that. Really, really weird how that didn't blow any fuses. Never mind. Just cleaning up that area there because there was a little bit of flux on it. But yeah, there's the donor board that I was using, and I do need that ribbon actually. That's actually a board I'm working on, but I can't figure out the issue. Again, it's got the same error code as this, but I just can't figure out the reason it's not turning on. Let's give this a test, shall we? I don't need that power button really, but I will pop it back inside the housing just because, well, why not? I've just got these ribbons in stock, by the way, on the online store. So not only these, but the LED ribbons as well. I've just managed to get them in stock, brand new ribbons for the 1000, 1100 and 1200 series boards. So brand new flex ribbons are now available. Someone asked me to try and source them, so I did. Okay, there we go. So this has already got fresh liquid metal on, so I don't need to put any more on. It is my own liquid metal as well, so I know it's fresh. Okay, so let's just see if this turns on, and if it does, I'll put a heatsink on. And it does. Awesome. There we go. So I'll put a heatsink clamp on this now, and then we're going to give it a test. Alright, there we go. So, time for the display test. So let's have a look on this screen just here. That's what I'm talking about. That is one working PS5. So I'm going to grab a disk drive for this. I'm going to pop in the daughter board, and hopefully it works with the disk drive as well. That is absolutely fantastic. It's cost me about £1 so far. So yeah, there we go. Fantastic. Right, okay, so I've got a disk drive here. This is a 1100 series disk drive. The EDM020 board is an 1100 series console, so obviously we need to match that up. If you can't match it up, if you've got a disk drive from another console, you could always just do a BD-ROM chip swap, which is going to be that chip just there on the daughter board. You could take that off, desolder it, and put that onto another board that does match. That's always possible. And I've just turned that console on by accident. I guess I should have unplugged it. Never mind. I'll wait for it to turn on properly, and then I'll shut it down properly. So I'm just stripping this disk drive down just so I can swap the board out on it. So I've just got to pop these ribbons out. Pop that board out. There we are. And then if we just pop this board in. There we are. And then I just need to pop these ribbons back in. So this can get rather tricky. It's just very, very fiddly to get this one particular ribbon in. You can take this entire disk drive out of the frame, but I'd rather just do it like this. It usually works out quicker. There we go. Let's just line everything back up. I'm going to shut this down, press and hold the power button until I get a second beep. And then while that's shutting down, I'll just line this up. I don't want to plug in this disk drive while the console's got power running through it, even just down to the console being in standby. You don't want to plug the disk drive in because it will very likely blow a fuse, and it could potentially damage the chip which is paired to the board, and then you're left with a console with no working disk drive. Right, just for the purposes of this video, it doesn't need every screw in. You know, the daughter board isn't going to stay in this console, in this disk drive. This disk drive actually belongs to another console which I've just recently repaired. So we're not going to be using this disk drive. I'm just going to connect up some antennas. There we are, that'll do. And then we're going to connect up the disk drive. So we just need the power cable to it and the flex cable. Okay, so there's that. There's that. There we are. And I'm going to connect up a fan as well. And I'll just rest the fan like that. and that will keep it sufficiently cool for testing. Okay, moment of truth. Does it recognise the disk drive? It does. And we'll pair it on. Good. And then I'm going to take a test game, Call of Duty Vanguard. Taking a disk. Okay, let's switch back over to the right input source. There we are. And there we go. There's the PlayStation logo. And that's not recognising a disk. Right, I'll check that out in a second. It could just be the disk that's gone faulty. I know that front panel don't work on this because the front panel itself is rusty. I can always test that at another time though. Actually, I think the USB-C might work. No, it probably doesn't. I'll just grab a Type A to Type C converter. Oh, yes, USB-C does work, never mind. And this controller is not working, of course it's not. Alright, so just for the purposes of testing, I've got a PS4 controller here. It's fine for testing the console. Okay, so sync the controller. Right, well, now I know why this died. He's got the FIFA virus. Of course he has. Okay, so let's just have a look at this then. So let's test the network. Okay, picks up my Wi-Fi. Okay, connected to the internet. Let's go to system, console info. And this is on firmware 9.0. It's been a while since this has been updated. I'm going to run an update on this. And in the meantime, let's just test another disk. Okay, it's not spinning a disk. So while it's downloading the update, I'm just going to really quickly check these ribbons, make sure that I've connected them up correctly. I think I have, but I'll just make sure. Okay, so we've got a 101312 error code, which is HDMI. Sorry, not HDMI, what am I thinking? It's disk drive error. I'm just going to restart that. Okay, now it's installing because I've got the disk drive plugged back in. So I just flipped the ribbons around and made sure that it was all connected. It is actually spinning a disk now, so that's always good news. And obviously that 10131228 error code has gone as well. So it's running through the update and it does appear as though it's recognising the disk drive. So we should be all good. Hopefully it's going to work. Okay, rebuilding the database. That is completely normal after an update. And there we go. Yep, Call of Duty Vanguard has picked up as a disk. That's absolutely awesome. And it's running 10.01, which is fantastic. That means that the update is working and this console appears to be working fine. There we go. So obviously I still need to give this a full test. I need to give it a proper stress test and stuff like that and make sure that it's going to work absolutely fine. But everything seems okay. It's recognising a disk. The console is obviously turning on. Yeah, it's obviously going to take me, you know, 8 to 10 hours to actually stress test this fully to make sure that we don't get any more issues. If we do, obviously I'd make another video and I would put something here because this console will be stress tested before I edit the video. But yeah, obviously I need to give it a stress test before I can even consider reselling it. But yeah, £80 for what's now a working PS5 motherboard with the matching disk drive isn't a bad price. It's a bit of a risk, but obviously, you know, you've got to spend money to make money at the end of the day. That's just the way it is. So yeah, thank you very much for watching. I really do appreciate it. Let me know what you think down in the comment section down below. And yeah, I do always read comments. I don't always get to reply to them. You know, I do get too many comments to be able to reply to everyone, but I do always read every single comment that people leave. If you do want to organise a repair, like I said, you can get in touch through the website www.thecodat.repair, and you can buy parts and stuff for these consoles on my online store, along with my own liquid metal, which, as you can see, even without the console being reassembled properly, it's working absolutely fine. I am going to be doing a comparison video tomorrow. I've got a PS5 just off to the side here. This has already got my liquid metal installed in it, but I'll put some fresh on just for the comparison. And then I'm going to take some thermal grizzly, and I'm going to do a side-by-side comparison. I've already got another multimeter, which is just here. I've also got thermal probes for my main multimeter, so I'll do a side-by-side comparison, and I'll test both of them individually, and yeah, we'll see how they perform. I've never tested it against thermal grizzly. I've only tested it against the stock liquid metal. But with that being said, thank you very much for watching. I really do appreciate it. Take care, everyone, and I'll see you all in the next video. Bye for now.